Hello everybody, my name is Anish from Greenfingers Global School. Today I am talking on the topic dielectrics and polarization. A dielectric is an isolating material in which all the electrons are tightly bound to the nucleus of the atom. There are no free electrons to carry current. Some of the examples of dielectrics are ebonite, mica or oil. The electrons are not free to move under the influence of an external field. Polarization. Polarization is a property of waves that can oscillate with more than one orientation. Electromagnetic waves such as light exhibit polarization, as do some other types of waves such as the gravitational wave. A non-polar molecule is one in which the center of gravity of the positive charges coincide with the center of gravity of the negative charges. Some of the examples of non-polar molecules are oxygen, nitrogen and hydrogen. A non-polar molecule do not have a permanent dipole moment. If a non-polar dielectric is placed in an electric field, the center of charges gets displaced. The molecules are then said to be polarized and are called induced dipoles. They acquire induced dipole moment P in the direction of electric field. A polar molecule is one in which the center of gravity of the positive charges is separated from the center of gravity of the negative charges by a finite distance. Some of the examples of permanent dipole molecule movement are N2O, H2O, HCl or NH3. In the absence of an external field, the dipole moment of polar molecules orient themselves in random directions. Hence, no net dipole moment is observed in the dielectric. When a dielectric field is applied, the dipoles orient themselves in the direction of electric field. Hence, a net dipole moment is produced. The alignment of the dipole moments of the permanent or induced dipoles in the direction of applied electric field is called polarization or electric polarization. The magnitude of the induced dipole moment P is directly proportional to the external electric field E. So, P is directly proportional to E. Now we are going to talk about polarization of dielectric material. So, for this, consider a parallel plate capacitor with plus Q and minus Q charges. Let E0 be the electric field between the plates in air. If a dielectric slab is introduced in the space between them, the dielectric slab gets polarized. Suppose plus Qi and minus Qi be the induced surface charges on the face of the dielectric opposite to the plates of the capacitor. These induced charges produce their own field, Ei, which passes the electric field E0. So the resultant field E is less than E0, but the direction of E is the direction of E0, and Ei is opposite to the direction of E0.